Hello guys, so welcome back to our class today. Now in our previous class, we studied the motion of bodies without making any reference to the force responsible for the motion. Well, in our class today, we'll be studying the effect of forces on bodies that are in motion. Now, this branch of study is called dynamics. Remember that in our previous class, we defined the force as any agent that changes or tends to change the state of rest or of uniform motion of a body in a straight line. And we mentioned that there are two types of forces in physics, the contact forces and the field forces. In that class, we went ahead to state that contact forces are those forces that are in contact with the body they affect. Examples include the tension force, the reaction force, the frictional force, the forces of pull or push. And then we said that field forces are forces whose sources do not require contact with the body on which they act. Examples include the gravitational forces, the electrical forces, and the magnetic forces. And we said that the effect of these forces is felt at a distance or in a field of the force. And that led us to define a field. And we said that a field is an area or a space through which the effect of the force can be felt. For example, the gravitational field, the magnetic field, and the electrical field. So in this class, we are going to be stating Newton's laws of motion and then their application. We are also going to explain the term inertia as it relates to the Newton's law of motion. And then we'll take it further by explaining the term momentum as an important property of a moving object and its relationship with impulse. And then we're going to also solve some simple questions involving Newton's laws of motion. Okay, now number one, Newton's first law of motion. This law states that a body will continue in its present state of rest, or if it is in motion, will continue to move with uniform speed in a straight line unless it is acted upon by a force. Or you can put it in another way. Every object continues at rest or continue to move with constant velocity in a straight line if no external resultant force acts on it. Now, it's important for us to note that every object in motion will always come to rest because a resultant force acts on it in order to oppose its motion. This opposing resultant force is what we call friction. Hence, if friction is eliminated, all moving bodies will continue their motion in a straight line indefinitely. Now, rockets and space shuttles, they give us evidence in support of this Newton's first law of motion. This is so because once they escape from the influence of the Earth's gravitational attraction, they continue to travel in a straight line with a constant velocity. So, this tendency of a body to remain in a state of rest or uniform motion is what we call the inertia of that body. And this is why Newton's first law is sometimes called the law of inertia. Just think for a moment the effect on a car driver. If his car is standing still and another car crashes into his car from behind, what do you think will be the observation? His car is suddenly going to be knocked forward. Now, this will in turn push his body forward. But if his car doesn't have a headrest, you will notice that his head will stay still in his state of rest and is jacked back in relation to his body. So this is the reason why we have neck injuries during accidents, and the major reason why modern cars have headrests to protect drivers and passengers from neck. Now, another important consequence of the first law or inertia is observed when a moving vehicle is suddenly brought to rest by the application of brakes. Now, the usual observation is that the passengers will suddenly be jerked forward because they will tend to continue in their straight line motion. In fact, in worst cases, passengers in the front may hit the windscreen, unless they apply enough force backwards. So this is why it is advisable to use a safety belt while at high speed. Okay. Secondly, it is also observed that passengers sitting on the seats in a stationary bus are pushed backward when the bus suddenly moves forward. Now this is so because the passengers tend to remain at rest. So the result is that it will fall backward in order to resist the forward motion of the bus. So all these and many more are some of the consequences of Newton's first law of motion. Hence, by way of definition, I could define inertia as the reluctance of a body to change its state of rest or motion in a straight line. Alternatively, I can say it is the tendency of a body to continue at rest or constant velocity in a straight line. So it is important for us to note that the mass of a body is what determines its inertia. This is so because bigger masses are difficult to move when they are at rest, or they are also difficult to stop if they are in motion. Therefore, this mass of a body which tends to keep it in a state of rest or in motion is what is referred to as its inertial mass. I can also define it as the measure of the reluctance of the body to move when a force acts on it. Number 2, Newton's second law. Now, this law can be stated as follows. The rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction in which the force acts. Alternatively, you could state it as acceleration of an object is directly proportional to the net external force acting on it and inversely proportional to its mass. So if I put this particular definition or law together, I'm going to get that F is equal to ma. Mathematically, change in momentum is written as mv minus mu. Momentum is simply the product of mass and velocity. We are going to talk about that shortly. So if we represent the law mathematically, we are going to have that the force F is proportional to the change in momentum, which is mv minus mu all over the time taken for that change. That is letter T. Trying to work it out and reduce it, we have m bracket v minus u over t, which also means acceleration. So if I simplify that equation, I would get that the force F, the resultant force F, is equal to mass times acceleration. And the unit of force is the Newton. Newton is defined as the unit of force which gives a mass of 1 kg and acceleration of 1 meter per second square. So this equation F is equal to ma is recognized as a fundamental equation of dynamics and is one of the most important equations of physics. Finally, Newton's third law of motion. This law states that action and reaction are equal and opposite, or you can state it as to every action there is an equal and opposite reaction. For example, if a moving car A hits a stationary car B, the force exerted on B by A, which is referred to as the reaction force, will be the same as the action of B on A. Now, this is the reason why both cars are damaged. Also, when a bullet is shot out of a gun, the person firing it experiences the backward recoil force of the gun. This is what we call the reaction force, and this is equal to the propulsive force or the action of the bullet. Now, this is so because forces always act in pairs. So from what I've said so far, what do you think we can deduce are some of the applications of these Newton's laws? Number 1, the recoil of a gun. I mentioned that while explaining the third law. Now, recoil of a gun. Number 2, jet and rocket propulsion. Now, this is observed when jets of hot gas are expelled downwards through the tail nozzle at a very high speed from the rocket to produce an equal and opposite momentum to push them forward. Number 3, it also helps us in walking. It is observed that the ground exerts an equal and opposite force back on a person that is walking when that person pushes with his or her foot against the ground. So it is this force on the person due to the reaction of the ground that moves the person forward. Now, going forward, considered as one of the most important property of a moving object, momentum is defined as the product of mass and its velocity. Momentum is defined as the product of the mass of that body and its velocity. Momentum explains the tendency of a body to continue moving in a straight line. It is represented using letter P, which algebraically is represented as mv, which is mass times velocity. It is a vector quantity and it is measured in kg meter per second. Now, it is important to note that momentum is proportional to the mass of a body if the velocity is constant. This is seen when we compare a basketball and a tennis ball. It is observed that the momentum of a basketball is greater than the momentum of a tennis ball if they are moving at the same velocity. Secondly, the momentum is proportional to the velocity of a body if the mass is constant. Now, this is observed when a fast-moving bullet penetrates a body more than a slow-moving bullet of the same mass. Also, impulse, which describes the impact of a force on a body, is defined as the product of the average force acting on a particle and the time during which it acts. It is also a vector quantity and measured in Newton seconds. And finally, from Newton's second law of motion, impulse can be derived or expressed as the change in momentum of a body. Having said that, we're going to solve just simple questions involving Newton's laws of motion. Number one, a ball of mass 0.3 kg moving at a velocity of 20 meters per second is suddenly hit with a force of 5 Newton for a time of 0.03 seconds. Find the new velocity of the motion. Now I'm going to advise you to pause the video and attempt this question using Newton's second law of motion. In that law, we derived that force is equal to ma or mv minus mu all over t. If you substitute these values into that equation, you will get the answer. So you can see from the simple substitution of the parameters given to us in the question, we got the final velocity of the body to be 20.5 meters per second. I believe that your answer is correct. Secondly, a ball of mass 5 kg hits a smooth vertical wall normally with a speed of 2 meters per second and rebounds with the same speed. Determine the impulse experienced by that body. Now, it's important for you to note that whenever a body rebounds off another body, that the value will be negative, and the negative would indicate a change in direction. Whenever I throw a ball on a stationary wall and that ball bounces off from the wall and changes direction, the value of the velocity of that particular ball will now be negative, indicating a change in direction. So you may now pause the video and attempt this question and get back. So you could see, earlier on I told you that impulse is equivalent to the change in momentum. So if from Newton's law I make impulse subject formula, which is Ft, then I can substitute the values given to me or the parameters given to me, where m is 5, u is 2, and v is minus 2 as a result of the change in direction. So if I substitute these parameters into the equation, I'm going to get that the impulse on that particular body is 20 kg meters per second. Hence, to challenge you, I'm going to be giving you just 4 questions as an assignment. Please do well to attempt these questions. You can comment on the comment section, share your challenges, share your experiences in attempting these questions, and then get back to me. I'll give you a reply. Now, once you do that, remember to stay tuned because we're not through with the topic. In our next class, we'll discuss the conservation of linear momentum. We'll talk about collision, elastic and inelastic collision, and then the difference between mass and weight. And we're also going to be deriving the weight of bodies in a lift and elevators. So I believe you've learned something today. See you next time.